Hello everyone, Namaskar. So, till now we have gone through electrostatics and electric charges and fields, and in this part we have discussed about point charges, Coulomb's law, these system of charges, okay, system of point charges, fields and interaction of fields with charges, and electric dipole and effect of frictional field on electric dipole. So these all things we have gone through. Now we have to move forward, we have to go ahead with some different distributions also. Electric charge which we see in charged bodies, certainly these are not point charges always. Some distributions, specific distributions are seen or are found in many cases. So here the topic various charge distribution is given. So various charge distributions are what? Charge may be distributed uniformly, may not be distributed uniformly in the system or body, depending upon the shape and material of the object. Okay. Normally in metals, when charge is given, it spreads uniformly on the surface, but it does not penetrate penetrate the interior, or you can say it does not reside in the interior of conductors. But in non-conducting materials, it is very difficult to give charge to non-conducting materials, but whenever charge is given to the surface of material, non-conducting material, it stays in that locality or it stays in that region. It cannot flow from one part to other part because material is non-conducting. And in many cases, some hollow spheres, sheets, linear distributions, volume distribution also, if some charge is given to material and it is needed like of clay, suppose this is non-conducting material, okay, then some charge is given to this material and again needed well, and dough is made or clay is turned many times, it is needed well, then what will happen? The charge will get distributed uniformly in the dough or in the clay. Being the non-conducting material, charge will not flow anywhere, and if charge distribution is uniform in the clay, it can be given the shape of ball, sphere, cube, cuboid, like a wire, like a sheet, etc. So let us come to that point. Charge distributions can be categorized normally as volume charge distribution. Electric charge is uniformly distributed in the material, and if charge is distributed uniformly on a planar sheet, then it is called surface charge distribution. Or if charge is distributed along a straight line in the conductor like in a wire, or in maybe non-conducting material also, but charge is distributed linearly, then certainly it is linear charge distribution. Let us see. Charge distribution are what? One, say charge, there may be many types of distributions, okay. So linear charge distribution, linear charge distribution. If electric charge gets distributed along a straight line uniformly, such as in a charged wire, so uniformly charged, you can say this may be uniformly charged straight wire, straight long wire, okay. This is linear charge distribution. and charge is uniformly distributed on the wire. So this is nothing special, charge is charge, it is distributed here. So charge is not a point charge, charge given is not confined in a point shaped, point sized body, okay, it is distributed along the long wire. So this is linear charge distribution. So for long wire we have effect of charge here. What is effect at this point? Generally it is found similar effect here, same effect you can say, identical effect here, and here also we see the same effect, This is line of charges, uniformly distributed electric charges. It means what? If charge is very long, so this point or this point has electric effect like the charge here. It means a point is affected by this region of charges, okay, and this point is affected by only charges in this region, and this point is affected by charges in this region, okay. Okay. So this charge is affected by charges in this region. So distant charges, they have negligible influence here. So this charge will not influence here, this charge will not influence this point, this charge will not influence this point. So generally we can say for us charge density is important here. What is density of charge in this region? Okay, so this linear charge distribution is characterized by linear charge density. So linear charge distribution is characterized by linear charge density, which is how much? Which is denoted by lambda, okay. So total charge on a segment of distribution, segment delta L of distribution, okay, distribution here divided by delta L. So this is how much? Delta Q upon delta L coulomb per meter. Its unit is coulomb per meter. Okay. So we can treat a small section of this distribution as point charge. Okay. Point charge. Okay. In calculations or in derivations, generally we use small sections. This wire is very large, so its small sections can be treated as point charges, okay, like point charges. So small sections, okay, point charge. Okay, so it is like that. Similarly, if charge is distributed uniformly on a surface, plane sheet, large sheet, then certainly it is surface charge distribution. This may not be sheet, it may be large spherical shape, spherical surface. So if charge is distributed, if electric charge is distributed, if electric charge is distributed uniformly on a surface. This may be plane or curved, so maybe there. Then distribution is surface charge distribution. So again, charge is uniformly distributed. If surface is large, certainly one end of surface or distant elements of surface, charge surface will not influence the distant points. So consider a surface here. Let this is a surface, it is uniformly charged. So a small section here, small section here, small section here, these are taken as point charges, okay, for distant points, point charges for distant observers, okay, observers means points. So these charges, this surface or this surface charge distribution is characterized by surface charge density. Okay, so this point is not influenced by the charges, or this point is not influenced by these charges because they are far away from this point. So definitely to the observer here, surface charge density is important. Total charge calculation is not much possible here. So charge density around the, because total charge is not known, so in the reachable surface, okay, in the reachable zone, what is amount of charge, or you can say what is density of charge here, it is important. So surface charge distribution, surface charge distribution is characterized by what? Surface charge density, okay, surface charge density. And this is what surface charge density only is taken. Why? Because for large surfaces, in case of large surfaces, vast distributions, we cannot calculate total charge easily, and influence of nearby charges depends upon density of charges on the surface. So definitely charge density is important, not the total charge. Surface charge density sigma here, charge on small surface element, this is what? Delta Q, and area of the surface element, area of the surface element, okay. So what surface element? We are considering area of that element only. So this is delta S. So this thing is what? Certainly you can write again delta Q by delta S, and this is coulomb divided by meter square. So remember, we have done the case of linear charge density, its unit was coulomb per meter, but here surface charge density has unit coulomb per meter square. So again remember, charge on a small element is taken as point charge for distant points or distant observers, okay. Now let us move to volume charge distribution directly, okay, nothing special to communicate here. So definitely let us move to that point, what? Volume charge distribution, or this is three-dimensional distribution. So volume charge distribution, okay. So when charge is uniformly distributed in the entire volume, okay, when electric charge given to the body distributes uniformly in the entire volume, in the entire volume. Okay. Then this distribution is called volume charge distribution. Okay. So this is there. So we again here we can consider a small volume element as point charge. Okay. So this is characterized by volume charge density. Okay. A small volume element of charged body, okay, body can be treated as point charge, can be treated as point charge. Then this point, and then we can write here, we can characterize, so we can characterize, okay, characterize the distribution by volume charge density, okay, and this density is how much? This is a rho, okay, charge in small volume element, charge in small volume element, this is delta Q, and divided by volume of this volume element, okay, and this is delta V. So rho is how much? Rho is delta Q by delta V, and this is coulomb per meter cube. So only one thing is special about units in distributions. In all distributions, these are large distributions, and we are taking small parts as what? Point charges. Generally, we consider for nearby points, whole charge distribution is not much effective, but density of charge near the given point where influence is being measured, it is important. So in all cases, we consider charge densities, not total charges, because distant charges cannot influence the given point. So be very focused here on charge density is important in these cases, and small elements of these distributions are taken as point charges. So these are very common and important things, and ahead we have to see what Gauss law and Gaussian surfaces, applications of Gauss law. So this is all about distributions. They are very simple things, charge distributions. So we will meet in the next video with Gauss law and applications. So thank you very much for being with us. Thank you for being with us.